In this video, we're going to be talking about transversals, and more specifically, how we can use transversals to find different angles when the transversal intersects two parallel lines. So first of all, let's talk about what a transversal is. A transversal is a line that intersects two other lines at different points. So for example, we have the two lines here, M and N, so line M and line N, and then we have this transversal. It intersects both of these lines, and it intersects them at different points. Therefore, this line here is a transversal, and M and N don't necessarily have to be lines in order for this intersecting line to be a transversal. M and N could be lines, they could be line segments, or they could be rays, and in any of those cases, we could have a transversal that intersects both of them at different points. So we're given two lines and a transversal. And when we have the special case where these other two lines, not the transversal, but the other two lines, are parallel to one another, we can do some really interesting things with the angle measures. So we've been told that lines M and N are parallel. These marks here indicate that the lines are parallel with one another. And we've been asked to find all of the angles in this figure that are congruent to angle number 1. So we have angle 1 up here, and we're looking for angles that are congruent to 1. Well, right off the bat, let's ignore for a minute line N and just focus on line M and this transversal here. So we're looking at this angle group here where we have the angles 1, 2, 3, and 4. Well, we just have two lines that are intersecting one another. So we know by the vertical angles theorem that opposite angles are going to be congruent. So angles 1 and 4 have to be congruent angles. So we'll say angle 4 is going to be congruent to angle 1. But that's not the only angle that's congruent to angle 1. And this is why it's interesting when lines M and N are parallel. This is why having these lines parallel is an interesting case. Because really, this transversal is intersecting M at the same angle that it's intersecting N, which means that 5 and 1 are also congruent angles. So we have to say angle 5 is congruent to angle 1 as well. And we actually call 1 and 5 corresponding angles. Now we know that angles 5 and 8 are vertical angles, which means that they are also going to be congruent. And if 5 and 8 are congruent, and we already know that 1 and 5 are congruent, then by the transitive property of equality, we also know that angles 1 and 8 are congruent. We could also say that 8 is a corresponding angle to angle 4, and since 1 and 4 are congruent, we know that 1 and 8 must also be congruent. So if we want to go ahead and indicate that all of these angles are equal, we could do something like this. These here are all equal angles, like this. Now what about angles that are congruent to angle 2? Well, we have angle 2 up here. We can see that angle 2 and angle 3 are vertical angles because we have T intersecting M. We just have two intersecting lines. And we know by the vertical angles theorem that opposite angles are going to be congruent. So 2 and 3 we can say are congruent. And then because M and N are parallel, we know that 2 and 6 are corresponding angles. So 6 is going to be congruent to 2 as well. And if 7 is a vertical angle to 6, they're opposite angles, we know 6 and 7 are congruent. And if 2 and 6 are congruent, we can say by the transitive property that 2 and 7 are also congruent. We can also say that 3 and 7 are corresponding angles. And since we know 2 is congruent to 3, by the transitive property, 2 is also congruent to 7. So we can say that 2 is congruent to angles 3, 6, and 7. And we could go ahead and draw in here that these 4 angles are all going to be congruent angles. And this is always going to be true when you have a transversal that intersects two parallel lines. You'll have this same system of congruent angles. Now we've also been asked here, if the measure of angle 1 is 130 degrees, find all of the angle measures. So if we've only been given the measure of angle 1, find the measures of angles 2, 3, 4, 5, 6, and 7. Well, that might feel like a tall order, only knowing one of the angle measures, but remember what we already know about the angles being congruent. We're saying that angle 1 is 130 degrees up here. We know that 1 is congruent with 4, 5, and 8. So we know that this is also 130, that 5 is 130, and that 8 is 130 degrees. Now all we have to do to get the other angles is recognize that angles 1 and 2 are supplementary angles, right? Angles 1 and 2 sit above the line M. If we look at the line M right here, the only angles above line M are 1 and 2, and they sit on this angle M, which means that the sum of angles 1 and 2 has to be 180 degrees because M is a straight line. So if the sum of 1 and 2 has to be 180 degrees and 1 is 30, then that means that 2 has to be 50 degrees, so we can say 130 plus 50 is 180. And then, of course, once we know the measure of angle 2, we know that 2 is congruent to 3, so we can say this is 50 degrees, also to 6, so this is 50 degrees, and also to 7. So this is 50 degrees, and instantly we know the measure of all 8 of the indicated angles. Now what happens when we apply this to a diagram that's just a little bit more complicated? Again, we have two lines, M and M. We've been told right here that they are parallel lines, and we have two transversals. So we have the transversal S and the transversal T. And if we look at them separately, let's pretend here that S isn't there for a second and just look at the transversal T. We can see that the transversal T intersects M at this point and N at this point. So it's a transversal because it intersects two different lines at different places. If we ignore T for a second and just look at S, we can see that it is also a transversal of M and N because it intersects M at this spot and N at this spot. We've been asked to find several things here, so let's go ahead and get started. We're looking for all angles that are congruent to angle 1. So if we look here at angle 1, we know that by vertical angles, angle 1 and angle 6 have to be congruent. So if we say angle 1 has to be congruent to angle 6. And remember that that just comes from the vertical angles theorem. No matter how many lines you have intersecting each other at one point, opposite angles are going to be congruent. So I can say 1 and 6 are congruent. I can also say that 2 and 5 are congruent because they're going to be opposite. And I can say that 3 and 4 are congruent. So 3 and 4 are going to be congruent also. So I can at least say that angle 1 is congruent to angle 6. Now, what about any other congruent angles? Well, if I look back at angle 1, I can see that angle 1 is the angle between the line M here, because I can mark M on this side, and the line T, the transversal T, because I can mark T up here, and this is going to be S. So 1 is right between M and T. So if I go look at the intersection of the line T with the line that's parallel to M, N, so if I go look down here, what I see is that 1 and 9 are corresponding angles. 1 and 9 are corresponding angles, which means that they're also congruent. 6 and 14 are corresponding angles, and I already know that 1 and 6 are congruent, so that means 1 and 14 have to be congruent. So 1, 6, 9, and 14 are all congruent angles, so I can say angle 9 and angle 14. Let's look at another example here. I have the angle 2. I'm looking for the angles that are congruent to angle 2. Well, angle 2 is right up here. By the vertical angles theorem, I know 2 and 5 are opposite, so they must be congruent. So 2 and 5 are congruent. I can see that 2 is sitting between S and T. Well, S and T don't intersect each other anywhere else. Now, if I look back here at the angle 2, what I see is that it's sitting between the transversals S and T. So 2 is not an angle between one of the transversals and one of the parallel lines, which means I can't go looking for other angles that are sitting on the other line that's parallel to this line M here. So 2 is going to be congruent to 5, and that's it. But angle 3 here, I'm looking for angles congruent to angle 3. We already know it's congruent to angle 4 by the vertical angles theorem because these are opposite angles. And if I look back at 3, I can see that it's sitting between M and S. So if I want to look for congruent angles to 3, I want to stay along the transversal S, but I want to go to the line that's parallel to M. So I'm looking for angles really between S and N. So that's going to be, of course, this angle here, angle 8, which is the corresponding angle to angle 3. So I can say that angle 3 is congruent to angle 8. And then I know that angle 8 and angle 11 are going to be congruent because they're vertical angles, but I could also say that I know that because 4 and 11 are corresponding, or if I know that 3 and 8 are corresponding angles and therefore congruent, and 8 and 11 are vertical angles, then 3 and 11 must also be congruent angles by the transitive property of equality. So angle 3 is going to be congruent to angles 4, 8, and 11. Now I'm looking for angles that are congruent to the sum of angle 1 and angle 2. So if I go find angle 1 and angle 2, I can see angle 1 and 2 right here. So when I add them together, it's this whole angle right here between M and S. So I need to look for angles that are congruent to the sum of these two. Well, by the vertical angles theorem, I know that the sum of 5 and 6, the angles opposite of 1 and 2, so if I add those two together, they're going to be congruent. So I can say the sum of angle 1 and angle 2 is congruent to the sum of angle 5 and angle 6. Now notice that angles 1 and 2 sit between the line M and the transversal S. So that means I want to stay along the transversal S and find the line that's parallel to M. So that means instead of looking for the angle between M and S, I'm going to be looking for the angle between N and S to be congruent to 1 and 2 here. And in fact, I can see that angle 7 is a corresponding angle to 1 and 2. So angle 7 right here corresponds to 1 and 2. That's going to be congruent to 1 and 2, so angle 7. Now by the vertical angles theorem, I know that 7 and 12 are congruent. So since by vertical angles I know 7 and 12 are congruent, I can say by the transitive property of equality that since 1 and 2 is congruent to 7 and 7 is congruent to 12, then 1 and 2 must also be congruent to 12, and I can say also congruent to angle 12. Now the last thing we're looking for are the angles that are congruent to the sum of angles 2 and 3. So if I find angles 2 and 3, I can see 2 and 3 right here. So that's going to be all the way from here down to here, angles 2 and 3 together. So I'm looking for angles that are congruent to 2 and 3. Well, by the vertical angles theorem, 5 is the opposite of 2 and 4 is the opposite of 3. So 4 and 5 right here, 4 and 5, I know by the vertical angles theorem has to be congruent to 2 and 3. So I can go ahead and say angle 4 plus angle 5 has to be congruent to angle 2 plus angle 3. Now the sum of angles 2 and 3 here are sitting between the transversal T and the line M. So I want to follow the transversal T down to the line that's parallel to M, which is N. So instead of looking now for the angle between M and T, I'm looking for angles between N and T that'll be congruent to angle 2 plus angle 3. So if I come down here to the intersection of N and T, I can see that 10 is going to be a corresponding angle to 2 and 3. So 10 is going to be a corresponding angle to 2 and 3, and therefore, because it's corresponding, it's going to be congruent. And then I can say by the vertical angles theorem that 10 is congruent to 13, so 10 is congruent to 13. And because I know that 2 and 3 are congruent to 10, and 10 is congruent to 13, I can say that 2 and 3 are also congruent to 13 by the transitive property of equality. So I can say 2 and 3 congruent to 13. And that's how you can use transversals of parallel lines to find the congruence of angles within the figure.